session. In this session, we'll discuss about the digital IIR filter design using that is from analog filter, Chebyshev filter, using either bilinear transformation method or impulse invariant method. Okay, so last few sessions we have discussed about the how to design IIR filter from analog filter, Butterworth filter using bilinear transformation or impulse invariant method. So in this session, the Chebyshev filter. Generally, the Chebyshev filter classified into type 1 and type 2. So compared to Butterworth filter, the Chebyshev filter will be that if you see the frequency response, sharp transition from the pass band to the stop band. So we can define the magnitude response square magnitude response of the Chebyshev filter for normalized low pass filter. So this is a magnitude square response is defined as 1 by 1 plus epsilon square Cn square omega by omega c. So the epsilon is a ripple factor. This is the attenuation constant ripple factor which is less than 1, which is a real which is less than 1. Where the epsilon square can be written in terms of dB. So epsilon squared is 10 to the power. So this is a passband ripple divided by 10 minus 1. So epsilon is equal to square root of 10 to the power passband ripple by 10 minus 1. So the gamma is a passband ripple in dB, where Cn is the Chebyshev cosine polynomial of order n. So in some other books the notations will be different. If you refer the Naukani book, in that the epsilon is given by 1 by ap squared minus 1 to the power 1 by 2. So ap is nothing but gain of passband h frequency omega p. So that Chebyshev cosine polynomial coefficient can be defined by Cn of x is cos of n cos inverse x, where the modulus of x is less than or equal to 1, and the hyperbolic function cos h of n cos h inverse x, where x is greater than 1. So the type 1 and type 2 difference. So if you see the frequency response, the type 1 is an all pole filter. There the frequency response passband equiripple in the passband and flat in the stop band. So monotonic characterization. So it's also called all pole filter. Then type 2, it contains both poles and zeros. So an equiripple in the stop band. So monotonic behavior in the passband. So the initial value for the C0 of x is equal to 1 and C1 of x is equal to x. For higher order polynomial coefficients can be determined by using this formula. Cn of x is equal to 2x Cn minus 1 of x minus Cn minus 2 of x. And for higher order polynomial coefficients, for example, n is equal to 2, then you can determine Cn 2 of x will be 2x squared minus 1. If you see the poles determination, how the poles are located in Butterworth filter and Chebyshev filter, the poles are located on unit circle for the Butterworth filter. Okay, there is a mathematical relationship between the Butterworth and Chebyshev filter. The poles are located in the Chebyshev filter in an ellipse manner. Okay, so in Butterworth filter, the poles are located on a unit circle. In Chebyshev filter, the poles are located on ellipse. For Chebyshev filter, the attenuation note. So note, if the maximum passband ripple is specified, then epsilon may be calculated. And if an attenuation passband ripple is specified, then you can calculate epsilon. And if attenuation is specified at a stop band h frequency, there's a stop band frequency omega. So if the attenuation is specified, you can use this formula to determine the order of the filter, 20 log 10 epsilon plus. So the maximum passband ripple is specified, the epsilon may be calculated, and if attenuation is specified, okay, the attenuation is dB. Okay, the attenuation in dB specified to particular stop band frequency. Then the order of the filter n may be calculated. by using this formula also directly. Log epsilon to the base 10 plus 6 of n minus 1 plus 20 n log of omega by omega c to the base 10 to the base 10. You can use this formula directly to find the order of the filter. And one more equation to find the order of the filter for Chebyshev filter in terms of hyperbolic function, cos h inverse, open the bracket, square root of 10 to the power 0.1 alpha s minus 1 divided by the square root of 10 to the power 0.1 alpha p. These are stop band attenuation and pass band attenuation minus 1 divided by cos h inverse of omega s by omega p. So you can use this formula also. Okay. In one more um, derivation for to find the order of the filter. So from the if you refer the Nagarkani book, so in that cos hyperbolic function of 1 by epsilon 1 by a squared minus 1 to the power half divided by hyperbolic function cos h inverse omega s by omega p. So you can write cos h inverse lambda by epsilon, cos h inverse lambda by epsilon. So hyperbolic function, or you can write n is equal to cos h inverse 1 by a squared minus 1 divided by 1 by ap squared minus 1 to the power half divided by cos h inverse omega s by omega p. Okay, so you can use any of the formulas depending upon the specifications given in the problem. So for example, for Chebyshev filter, for Chebyshev filter, the given specifications are omega p is equal to 20 radians per second, 20 radians per second, 20 radians per second, and omega s is equal to 50 radians per second, and alpha p is equal to 2.5 dB, and alpha s equal to 30 dB. So find the order of the filter. So n is equal to cos h inverse of the square root of, so use this formula 10 to the power, you can use this formula 10 to the power, the alpha s and alpha p is given, alpha s, alpha p, omega s and omega p is given. So you can take this formula. So 0.1 into what is alpha s, 30 dB, 0.1 into 30 dB will be 3. So you can substitute this is a 10 to the power, you can write 0.1 into alpha is equal to 30, no, 30 minus 1 divided by cos this formula, cos h inverse of this one divided by 0.1 into alpha p. What is alpha p? 2.5 dB. So 2.5 means 0.25 will get. So 0.25. So 0.25 square root of 10 to the power 0.1 into 2.5. So 0.25 will get 2.5 dB minus 1. So use this formula. Okay, cos L divided by cos H inverse divided by cos H inverse of omega s by omega p. So omega s is 50 and omega p is 20. So now you can calculate n is equal to, use calculator and compute the order of the filter. So cos n H inverse of 35 point. You can cross check the value step by step. Then you proceed to the next step. Cos H inverse of this is 2.5, which is equal to hyperbolic function. That's why I am writing all the numerical values step by step. You just use calculator and cross check whether you got the answer or not. Then you proceed to the next step. 2.726. So you can approximate n is equal to approximately equal to 3. So the order of the filter is 3. Okay, so how to determine the order of the filter? By using Chebyshev filter. Depending upon the given specification, you can choose either one of these formulas. Okay, alpha is alpha p, omega p is given. You can choose this formula. In terms of a and there is a passband gain and stop band gain is specified. Then you can determine, you can find out the decibels and you can use any one of the formulas. Okay, so these are different ways to find out the order of the filter. Similarly, the pole determination also important. Pole determination. If the angle of the kth pole is denoted by pi k, the angle of the pole, this is the angle of the pole. The angle of the pole is denoted by pi k, where k is equal to, where k is equal to 0, 1, 2, up to 2n minus 1. In some books, the notation may be k equal to 1, 2, up to 2n. Okay, for example, n is equal to 10, n is equal to 5. N is equal to 5 means 2n is 10. So 1 to 10 you can say, otherwise 0 to 2n minus 1. Okay, 1 to n, 1 to 2n, 1 to 2n or 0 to 2n minus 1. Either way you can specify. So here 0, 1, 2 up to 2n minus 1. And all are located on the, so the poles are located, how the poles are located on the circumference of the S plane, circumference of the unit circle, circumference of the unit circle in the S plane, in the S plane. So the location of the pole is determined by pi k is equal to k pi by n, n is equal to r, and pi k is equal to k plus 1 by 2 of pi by n for n is equal to even. Once the values of n is known, note down, once the values of n is known, then the position, then the position, then the positions of the S plane, position of the S plane Chebyshev filter, S plane Chebyshev poles may be determined. How? May be determined. So once the values of n is known, then the position of the S-plane Chebyshev filters may be determined. A straight forward, so this is important. A straightforward, a straightforward way is to determine Butterworth poles and translate to Chebyshev poles, Chebyshev poles. So a straightforward way to determine the Butterworth force and translate to Chebyshev force, because this is because of, so this is because of geometrical relationship, the geometrical relationship between Butterworth force, Butterworth force and Chebyshev force. Chebyshev force, that is a Chebyshev force. Because what are the poles are located in the unit circle can be translated into the ellipse. There is a circle. Whatever poles are located in the circle can be translated into ellipse. This is a geometric relationship between Butterworth poles and Chebyshev force. So now the design parameter A can be defined. A design parameter A can be defined 1 by n sine h inverse of 1 by epsilon. So the real part of Chebyshev filter, okay, for example P2 can be determined by the real part of Butterworth P1 into tan HA. So once the poles of Butterworth we determine, then how to determine these two will, by solving the problem you come to know how it is determined. Okay, so for example the valid poles of the Butterworth poles are B1 and B2 can be determined by A plus, for example Butterworth poles B1 is equal to A plus JB and Butterworth poles B2 is equal to A minus JB. So how to determine, I'll tell you the steps. Okay, normalization how to do. Chebyshev folds are C1 and C2 how to determine, I'll tell you. So the Butterworth folds are B1, B2, Chebyshev folds are C1 and C2. So any poles P1 into tan HA, real part will be, an imaginary part of Chebyshev filter of P2 will be imaginary part of Butterworth as such. So P1 is given, P1 is a Butterworth force, real part and imaginary part. For imaginary, for Chebyshev force, the real part will be, the new Chebyshev force will be calculated by multiplying the real part with the tan function, tan hyperbolic function, and Chebyshev filter imaginary part as such. And the P3, the new force will be calculated, Chebyshev of P3. So Chebyshev of P2 into cos HA. So these formulas are very important. How to find, how to convert your Butterworth force into Chebyshev force. So if you see the Chebyshev design, okay. Similarly, here also we have to consider only the poles between 90 and 270 degree only. Okay. So the Chebyshev design, first step you take the valid Butterworth poles. So B1 is equal to A plus JB and B2 is equal to A minus JB. Then second step, find A is equal to 1 by n sine h inverse of lambda by, sorry, not lambda, 1 by epsilon is 1 by epsilon. Then once A if you find out, then find tan HA and cos HA. Then multiply the real part, multiply the real part, multiply the real part by tan HA. This is called normalization. This is called normalization. Then the normalization, it is it? Then the normalization poles. So B1 dash A tan HA plus JB, and B2 dash will be C tan HA plus JD. Now denormalization, the next step. Now denormalization we have to do. Now denormalization by multiplying cos HA for the desired Chebyshev force, for the desired Chebyshev force. So now C1 is equal to cos HA of A tan HA plus JB, and C2 is equal to cos HA of C tan HA plus JD. Once the poles are determined, the transfer function can be written as h of s is equal to this p by s plus c1 and s plus c2 and s plus c3, s plus c4, and then you can write the transfer function where p is equal to the concatenation of c1, c2, c3, like that will go. Okay, so now we'll take how the poles are located, how to convert the butterworth poles into Chebyshev poles. Here also I'll remind that the butterworth poles, how to determine, we know that. Okay, for example, the angle of poles for the butterworth poles for any equal odd and even also I'll remind it here. So pi k is equal to k plus 1 by 2 of pi by n for n is equal to even, and pi k is equal to k pi by n for n is equal to odd. How the poles are located, the angle of poles, how the poles are located. So this is B0, this is B1, this is B2, this is B3. How the poles are located here. Okay, but for stability we consider only on left hand side of this plane. Explain between 90 degree and 270 degree. For stability we consider only left half of the S plane. Okay. These are the concepts of Chebyshev filter, how to design, how to find the order of the filter. Okay, so in this session we'll conclude with this concept. So next session we'll discuss about the we'll solve some of the problems depending upon the given specification. how to find out the order of the filter, how to find out the angles of the poles, and how to write the unlock transfer function, how to convert your unlock transfer function to digital transfer function, either by using bilinear transformation or inverse invariant method. Okay. So the questions how to, so here the main concepts are the comparison of Butterworth filter and Chebyshev filter, how the magnitude frequency response is specified, how to find out the order of the filter, then how to find out the angle of the locations. So what is the geometrical relationship between your Butterworth and Chebyshev filter? Once if you know the Butterworth filter, then how to find out the Chebyshev filters by using these steps. Okay. So all the steps we derived here. So next session we'll discuss about the problems. Okay, we'll solve one or two problems with respect to the given specification, how to determine all the other parameters. Okay, with that we can conclude this session. Thank you.